Let's begin by enabling the Windows feature required for WSL. Open your terminal in administrator mode and run these two commands. This enables the necessary Windows components. Once that is done, it's usually recommended to restart your computer, so go ahead and reboot. After the restart, relaunch the terminal. We can install WSL now by typing WSL install. This installs the Windows subsystem for Linux and by default Ubuntu distribution, which is what I'll be using here. Once installation is completed, Ubuntu will launch automatically. Set your username and password. That's the first time setup, and now we are logged in. I will exit for a moment so we can check a few details. Back in Windows Terminal, let's check which version of WSL is installed. If it's not version 2, upgrade it using appropriate command. Everything looks good on my system, so I will close the terminal. Let's open Ubuntu again and prepare it for development. Before installing anything, it's a good idea to update and upgrade the system. This pulls the latest and greatest packages. Once the upgrade is finished, I will relaunch Ubuntu. Now let's install the tools we need for C++ development. Build Essential, CMake and Ninja Build. We will be using Ninja because it's faster than Make. So run this command sudo apt install build essentials, CMake and Ninja Build. In my case, everything is already installed, so nothing new happened. On your system, this may take a bit longer. Now let's create a small test project to verify the build environment. I will create a folder called hello cpp and inside it a main.cpp. Main.cpp will be a minimal hello world program. Instead of compiling manually, we will set up a simple cmake list.txt. I am using C++ 17 because later I'll be compiling for embedded hardware like STM32 or TI, and many of those toolchains don't support C++ 20 yet. Next, create a build folder to keep all build artifacts separate. Inside the build folder, run cmake-g ninja. This tells CMake to generate Ninja build files. It ran without error, so let's build the project. You will see the hello executable appears. Let's run it and it prints hello world. That confirms our environment is ready for compilation. Now let's set up Google Test for unit testing. Install the package libgtestdev. Google Test is shipped as source, so we need to compile it manually, and once it's built, copy the generated libraries into userlib. This makes Google Test available system-wide. Inside our project, let's create a test folder and add a test file. We will write a simple test using Google Test. We also need a cmake list.txt inside the test folder to build the test executable and link it with Google Test. Now modify the top level cmake list to include the test subdirectory. And let's build the test. The first build fails because we forgot to include the header. Let's fix that and build again. This time it succeeds. In the build directory you will find the run test executable. Let's run it. And you can see the test passes in green. That means our build and test environment is correctly set up.